Today I'm gonna talking about the thread in operating systems. What is a thread? A thread is a basic unit of CPU utilization. A thread is the flow of execution through the process code with its own program counter, system registers, and stack. A thread is also called a lightweight process. Threads provide a way to improve application performance through parallelism, and it is always performed in multi-threading implementations. So each thread belongs to exactly one process, and no thread can exist outside the process. So here are two types of processes: the single-threaded and multi-threaded processes. So the multi-threaded processes shared with other threads belonging to the same process. Its code section, data section, and other operating system resources such as the files and the signals. As I mentioned before, the in multi-threaded process, each thread has its own unique registers and stack. Here are the concepts of multi-threads. Some operating systems provide a combined user level thread and kernel level thread facility. Multiple threads within the same application can run in parallel on multiple processors, and the blocking system call do not need to block the entire process. So here are three types of models. The first type is many to one model. In the many to one model, many user level threads are all mapped into onto a single kernel thread. The thread management is handled by the thread library in user space, which is efficient in nature. And for this types of model, the entire process will block if a thread makes a blocking system call. And the second type is the one-to-one model. The one-to-one model, each user thread maps to one kernel thread. It provides more concurrency. If one thread makes a blocking call, other threads are still allowed to run. Creating user thread requires creating corresponding kernel thread. And for the third types of the multi-threading relationships, it's a many-to-many model. The many-to-many model multiplexes many user-level threads onto an equal or smaller number of kernel threads. It combines the best features of the one-to-one and many-to-one models. In this type of model, developers can create as many user threads as necessary, and the corresponding kernel threads can run in parallel on a multiprocessor. Also, when a thread performs a blocking system call, the kernel can schedule another thread for execution. Here are two types of threads. The first type is user level thread, and second type is uh, kernel level threads. So for the ULT implement in user level libraries. So thread switching does not need to call operating system and to cause interrupt to the kernel. In fact, the kernel knows nothing about user level threads and manages them as if they were single threaded process. The advantage of the ULT are user level threads does not require modification to operating system, and it is easy to represent and manage. User level thread can run on any OS. User level threads can be fast and efficient. And the disadvantage is there is a lack of coordination between threads and the operating system kernel. The ULT require non-blocking system call. And the second type is KLT. In this method, the kernel knows about the managers and the threads. No runtime system is needed in this case. Operating system kernel provides a system call to create and manage threads. The advantages are kernel can simultaneously schedule multiple threads from the same process on multiple processes. If one thread in the process is blocked, and kernel can schedule another of the same process. The kernel routines themselves can be multi-threaded. The disadvantage of KLT are kernel thread are generally slower to create and manage than the user threads. And the kernel requires TCB, the thread control block, for each thread in the pool. Hence, the complexity increases. And for the benefits of multi-threaded programming, the first one is responsiveness. Multi-threading an interactive application may allow a program to continue running even if part of it is blocked or is performing a lengthy operation, thereby increasing the responsiveness to the user. And the second one is resource sharing. By default, threads share the memory and the resources of the process to which they belong. The benefit of sharing code and data is that it allows an application to have several different threads of activity within the same address space. And the third one is economy. Allocating memory and resources for process creation is costly because threads share resources of the process to which they belong. It is more economical to create and context switch threads. The last one is utilization of multiprocessor architecture. So it is increased in the multi-threading efficiency is increased in the multiprocessor architecture, where threads may be running in parallel on different processors. A single threaded process can only run on one CPU, so no matter how many are available, multi-threading on a multi-CPU machine increase concurrency. And here's the problem. So this is the software implementation of running 20 virtual computer system operations. Each operation takes 1 second to run, so there is 20 seconds in total to finish these 20 operations in a line. Please add 4 threads to invoke the instruction OP function method to OP function to do the operations so that the running time is reduced to 5 seconds. So in this code, the 20 operation is created here by using the for loop to iterate 20 times and initialize the OP in type of string and cause the instruction function here. And the instruction function is just using a sleep function to have a 1 second delay to perform that each operation cost 1 second to run. And for the output of the problem, we can see that we can only look at the last digit of the output. So it become 91 from 71. So it's 20 seconds in total. And I use the current time millis function to perform at the milliseconds level, so I divided by 1,000. So here's in second. So there are 20 seconds total and 1 second for each operation. Here is the solution. The 4 threads are created to run the instruction OP method. The Java concurrent library is used for creating the blocking queue. So the blocking queue is here. It is created as an array blocking queue of type string and the size of 1. What does this blocking queue do? This blocking queue is used to transmit data between threads. So it is a queue of size 1. In this form, the queue only can be pushed or popped one at a time. And here are 4 threads are created, and in each of the thread, the OP operation is created in type of string and use the queueTake function to pop the data of the OP from the queue. and call the instruction OP function just after that. So in the instruction OP function, here is exactly same as the problem. It provides 1 second delay to run each operation, and at the middle the 20 operations is created here, and here's the one extra thing is queue put. So the queue put OP just push the OP into the queue if the queue is not full. So in this situation, the mutual exclusion is achieved by using the blocking queue, and the deadlock is also avoided. So let us look at the output. The output is the starting time is 23 and the ending time is 28. So it is 5 seconds in total. So it is actually reduced to 5 seconds. At the beginning here are 20 seconds, and we use 4 threads. So finally we got the 5 second running time. So the 4 threads are running concurrently, and it is greatly reduced the runtime of this system. So it is I think it is the biggest benefit of the multi-threading implementation. Okay, thank you for watching.